Okay, we're doing ordinary differential equations here, question 3c, particularly doing substitution. So we have the derivative dy dx is equal to 2xy plus 3y squared over x squared plus 2xy. So the whole point is to get down to y is equal to something. So we try and integrate it to get rid of our dy dx, but we can't because we have x's and y's mixed. Then we'll try separation. We'll get our x's with our dx's, our y's with our dy's, but that'll be a problem for us as well. So instead we'll try substitution. So as before I said, we'll be substituting it for v, but we'll let it equal to y over x. So I'll rearrange that. So y is equal to vx. So everywhere I see y now, I'm going to replace it with vx. So dy dx is equal to 2x, and instead of y, vx, plus 3, and instead of y squared, it'll be vx, all to be squared, all over x squared plus 2x times, and instead of y, vx. Okay, I'm going to tidy that up some. So dy dx is equal to 2x squared v, let's say, plus 3 x squared v squared, all over x squared plus 2x squared v. Okay, so I want to simplify that down again. As we can see, everything in my fraction could be divided by x squared, and that'll get rid of a load of problems for me. So dividing everything by x squared, that gives me 2v plus 3v squared over 1 plus 2v. Okay, so now I need to get rid of my dy dx, because if I'm going to integrate v's, I need a dv dx. So again, we go back up to our y is equal to vx, differentiate it, so dy dx is equal to, and that's going to be v plus x dv dx. And if you can't remember how to do that, look back at the first video from this set of substitution, and it's explained. It's just a product rule. So I'm replacing my dy dx with v plus x times dv dx equals to 2v plus 3v squared over 1 plus 2v. Okay, nearly there. So I'm going to bring my v over. It'll become minus v. So x dv dx is equal to 2v plus 3v squared all over 1 plus 2v minus v. Now I might as well tidy up that right side. So v, if I was to write v as a fraction, it would be v over 1. You can write anything over 1 to make it a fraction. And sometimes people like doing that just so they can get the common denominator, and it's kind of easier, it's visually easier for them to do it. So 1 plus 2v, and that's 2v plus 3v squared, and then 1 plus 2v needs to multiply this minus v. So that gives me minus v minus 2v squared. Alright, we tidy up again. So x dv dx is equal to 2v minus v is just v, and 3v squared minus 2v is plus v squared over 1 plus 2v. Okay, so now it's time to get dx's with x's and so on and so forth. So what I'm going to do is I've got a dx here. I'm going to bring it over to multiply. I've got a 1 plus 2v here, and I'm going to bring that over to multiply. So I've got x times 1 plus 2v times dv equals v plus v squared dx. Okay, and then lastly, get my x's, my v's with my v's. So I need to get this guy over to the other side. It's multiplying the dx, so when it comes over it will divide. So it'll be 1 2v plus 2v dv over v plus v squared, and this x on the right, which are left, which is multiplying, will come over to the right to divide. That'll just be dx over x. Okay, now our v's are with our v's, our x's with our x's, so it's an easy integral. Well, it's easy on the right anyway. So that's the integral of 1 over x, which is the natural log of x. And the left-hand side then, it's a little bit trickier. It's not that easy to do. So what I might do is do integration by substitution. So I'm going to let u equals, so I noticed that the derivative of the bottom would give me the top, and that's always handy. So v plus v squared. So when I differentiate du dv, it's going to give me 1 plus 2v. And bringing my dv across, du can be exchanged for 1 plus 2v dv. Perfect. So here I've got a du, and I can exchange it for 1 plus 2v dv, which is my top line here. So I can rewrite that now as 1 over u and du. So the integral of that's easy. That's just the natural log of u. Equals the natural log of x, and I forgot my plus c. Okay, now nearly there. So we have to bring back in our u, so that's the natural log of v plus v squared is equal to the natural log of x plus c. All right, and now I've got v plus v squared v plus v squared is equal to, now remember how a log works, so e to the power of all of this will give me this back again. So e to the power of the natural log of x plus c. And remember from our previous videos, e to the power of natural log of x is just x, and then I still got my e to the power of c. Now, this is where it gets difficult at the very, very end. You could sub in your y's now, but it's easier if we can solve as much as we can for the moment. But when we have this situation where v plus v squared equals x e to the power of c, I'd rather just have v is equal to it, make my life an awful lot easier. And we did this in a previous video where we had to manipulate it now using completing the square. I'll explain that one more time. If I've got a quadratic, let's say x squared plus 3x plus 4, well, in this case I'm going to leave out the 4. It'll suit us a bit better. So you can have a number after it, it doesn't matter. But if you take the coefficient of the x, which is a positive 3, you half it, which is 3 over 2, and you square it, which will give you 9 over 4. So you take your quadratic, x squared plus 3x, and you add and you subtract that thing you just found. Now, if you add it and subtract it, it means you're adding 0, which means you haven't changed anything. But what it allows you to do is to factorize the first 3 terms. And you'll be able to write that as x and a squared here, and then this number that you halved will always go next to the x, and then I've still got my minus 9 over 4, and that's going to be really useful for me here. So first thing I'm going to do is just rearrange a little bit. V squared plus v equals x e to the power of c. So I've got my quadratic here, and my coefficient of the v is 1. So I'm going to take that, I'm going to half it. Half of 1 is a half. Then I'm going to square it, and that's going to give me a quarter. Now what I'm going to do is I'm going to add that and subtract it. So I've got v squared plus v plus a quarter minus a quarter equals to x e to the power of c. Now I can factorize my first 3 parts there, factorizing a quadratic to be v, and it's always the thing that I halved, which is plus a half in this case, then minus a quarter. That's equal to x e to the power of c. Now keep going. So I've got v plus a half 2b squared, so I'm going to bring my quarter over, so v plus a half is equal to x e to the power of c plus a quarter. And I've got my squared here, apologies. Alright, last thing, get rid of my squared there now. So I've got v plus a half, so if my squared comes over, it becomes square root. X e to the power of c plus a quarter. And don't forget that square root, we're going to need a plus and a minus version of it at the end. Okay, we're nearly there. So then I've got v is equal to the positive and negative square root of x e to the power of c plus a quarter. And then I've got my minus a half. Now, of course, we didn't have v. What is v? V, of course, is y over x. So y over x is equal to plus or minus the square root of x e to the power of c plus a quarter, and then minus a half outside. So I want y on its own, so that x is going to go over to multiply. So it'll be plus or minus, and it's going to just have my, actually, let me think, I'll have my x here. X, I'll rewrite that, makes it looks a bit messy. It'll be x times the positive or negative square root of x e to the power of c plus a quarter minus a half. Now you need to write that as 2 solutions, so write it as x plus the square root of 1 quarter minus a half. Now remember, this plus and minus only applies to the square root. That minus a half will stay a minus a half, but present your 2 answers separately then.